Today we're going to talk about special products of polynomials. In the last section we talked about how to do the product of two binomials either by using the FOIL method or the box method. One of the things that we're going to be trying to get you to do is to notice some of the special ones that you will come across to try to save you some time and to try to be able to help when we start factoring the polynomials in some later sections. So, first we have what we call the sum and the difference pattern. So what this basically means is that when I have two binomials where one is a plus b, and we are multiplying it by a minus b, we can simply, without having to do the FOIL or without having to make the box, make the pattern a squared minus b squared. So for example, if you look at this next one with the numbers and the variables, x plus 3 and x minus 3 simply becomes the first term, which is the x's squared, and then you have the b, which in this case would be the 3's, and so you have 3 squared, and then x squared minus 9. So just to kind of prove how this works, so let me just kind of redo x plus 3 and x minus 3. So if I decided I want to use the FOIL method, remember we would say first terms multiplied by the first terms is x squared. Then the outside terms, you would get minus 3x. Then the inside terms is plus 3x. And then the last terms gives you the negative 9. Now what you're going to notice here is the negative 3x and the positive 3x will cancel, leaving me with the x squared minus the 9. So that kind of shows you how the pattern does work. And again, it's not to say that when you see this pattern of two binomials being multiplied together, you certainly could just multiply them the way you did in the previous section with FOIL or with the box method. But if you can recognize the pattern, it will be much more helpful later on when we have polynomials that we are trying to what we call factor, which is to pull them back to x plus 3 times x minus 3. So it's worth trying to take a look and trying to recognize some of these patterns. And obviously what you are looking for is trying to recognize the two terms within each of the binomials that are the exact same, where they are adding in one and subtracting in the other. So here's another example. So down here we have x plus 7 and x minus 7. So again, what we would do is we would take the first term x's and square them. We would take that second term of the 7's and we would say subtract 7 squared. And then obviously we can do a little bit more work there to say x squared minus 49. Then looking at the next one, here's where we got to be a little more careful. We are now taking the 3x, which is my a, and squaring it. So 3x, and we are squaring that whole term. We have a minus 1 and a plus 1, so we are subtracting 1 squared. 3x squared becomes 9x squared, and we are still subtracting the 1 to get 9x squared minus 1. And again, you certainly could do your FOIL and get that same answer. You would have those middle terms cancel each other out, but if you can recognize the pattern, it will eventually be more efficient for you and you'll be able to move along a lot quicker. Next we have the square of a binomial pattern. This one is a little bit more difficult to kind of understand, and with the two examples you see here, it's a little more trying to figure it out. But basically what you are looking at here is you will see that if I have two terms where we are adding them together and we are squaring that binomial, you are going to get what we see next to that. We're going to square the a term, we are going to square the b term, and then what we're going to do is multiply 2 times a times b, and that's going to be our middle term. So how that would look as far as an example goes, if you move over to the right, we're going to have x plus 3 squared. So again, you square the first term. You are going to plug in 2 times x times 3, which are these x and 3's, and then you just double it. And then you have the last term, which is the 3 squared. And again, 2 times 3 times x gives you the 6x, and that's where the x squared plus 6x plus 9 comes in. Again, remember this time though, if I am going to try to just multiply these out, remember x plus 3 squared would be x plus 3 times x plus 3. And that does not really fit well. So let me just take that out so we see that again. x plus 3 squared. Remember, if I decided I just want to multiply this out, just remember that this is x plus 3 times x plus 3. Now if I have the square of the binomial pattern with a subtraction sign, as we do down here on this next example, we have a minus b squared. This time nothing's really different except that the middle term is going to be minus, so this is going to be a minus. Notice though how at the end here this is still plus b squared. And if you think about that, reasoning being that a minus b, which is a minus b times a minus b, if I was to do the FOIL out, those last terms would be negative times a negative to get back to that positive. And you can certainly see the example next to it. X minus 3 becomes x squared minus 6x, but still plus 9. So here's our two examples. So if I'm doing y minus 1 squared, okay, the a value is the y, so we're going to do y squared. We are then subtracting 2 times the a, which is y, times the b, which is the 1. And then we are adding the b squared, so 1 squared. So this is going to become y squared minus 2y plus 1. And lastly, 2x minus 3 squared. Again, we are taking the a, which is the 2x, and squaring it. We are subtracting 2 times 2x times 3. That's the 2ab. And then we are adding the 3 squared. 2x squared becomes 4x squared. We are then subtracting 2 times 2x times 3, which is minus 12x. And then we are adding the 9 at the end for the 3 squared. That's as reduced and simplified as we can go. And there you have the two special patterns that we can do for multiplying these binomials. Again, we can always use the FOIL method to do these. I think it's worth your time to try to learn these two special products, because it will definitely come in handy and help you speed up things and help you find easier answers as we go into the rest of chapter 7 while we talk about factoring polynomials.